Okay, in the previous lesson we have talked about the how we can use the OpenCV and its library, especially for the webcam or the YouTube or the any other algorithms that's used to be in the what in Python programming language. And so in this lesson we will mainly focus on the face recognition algorithm in the OCV process. .py. Okay. Yes, Emre, but the other guy that's missed the exam cannot be communicate with me. Okay, and so in the next week I will prepare your exam and I will take the Python programming exam for you. Okay, in the next week I will do that. Okay, so firstly, in this lesson we built the face recognition algorithm. Okay. Next one, face recognition algorithm using using the OpenCV library. Okay, and so we need to import the CV2 in here like this one. Okay, and in this lesson I will utilize the another process or the feature of the Python programming language. Okay, which is the main keywords in here. Okay, in this keyword, if we have this definition in the if process or the any Python programming language, and so this is called the main function body, like in C or C++ programming language. For example, if we have this syntax or the conditions, and then our program will start the whole process at this line, for example 17. Okay, and so in the upper side or in the up down codes is what is represented or the run after this code is run. Okay, and so we create an instance of the face recognition class in here. Okay, which means that we need to define the face recognition body or this class like this one, and so we want to build this class definition in the upper side of the name or name main study. Okay, after that we define another code in here in order to start the face recognition algorithm like this one, and so the face recognition called with the run face recognition function. Okay, and so this class must be written by us in here, and then we will add the run face recognition function in order to get the webcam pictures or detect the face from a given the image. Okay. And so firstly we should define the class face recognition in here like this one. Firstly we need to create the constructor of these terms with the parameters of the self and camera index, which is equal to 0, which means that if we have this camera index or if we define this term and equalize to 0, and then this implies that our webcam is utilized to get the whole pictures from the system or in this code. Okay, and so if we have this nomination, and then we can create this face cascade structure, which means that the CV2 contains the many classifiers for an image processing, and one of them is the cascade classifier. Okay, this cascade classifier returns to the some image processing tools or the output matrices in order to what? In order to get the face from a picture. Okay, and so we need to give the what? The CV2 data, and we can add the hair cascades. You don't need to know that this hair cascade, but this is the simple filter to be what? To be used in face recognition algorithms. Okay, and so we should also give the what? The some parameters in here, like this one, the hair cascade frontal face default XML. Okay, and so this definition is coming from the what? We have the XML file in here with the what? With the coefficients of the hair cascade frontal face default parameters. Okay, it's kind of filter, but the whole filter coefficients is contained or stored in the what? This XML file. And then if we use this structure, and then we can build the what? The cascade classifier in here. For example, we can use the what? The Sim4 filter, or the what? Wavelet filter, or the what? The Fourier filter, in order to what? In order to build the cascade classifier. But firstly, we need to define these terms, which default XML file it's given in our system, and then we need to add this nomination in here to what? To get the picture or the face from the what? Image. Okay, after that, for the initialization process, we should create the what? The self cap parameter in here with the what? CV2 video capture, and so we should also give the what? The camera index. Okay, and so this index represents the what? The utilization of our webcam camera. Okay, and also we can build the what? The self cap set parameter in here, CV2 cap prop FPS, which means that this determines to the what? To our frame rate per seconds for a given what? The webcam. For example, I can set to what? The 30 in here, which means that we get the 30 images in 1 second. Okay, this is our basic constructor. But how can we create the what? The dev run face recognition algorithm? We should firstly give the what? The self, because it's syntax for the Python programming language, and then we should firstly to what? The if not self cap is opened should be checked in here, and so cap is the what? The attributes of the R face recognition class, which means that we can utilize to what? The self in order to reach the cap parameter in here. Okay, and then we can print the what? The error could not be or could not open camera in here, and we should return the whole the process. But if this is not the case, and then we should create the what? The while true. It's an endless loop for our process, and we should define the read and frame section in here, like this one, the self cap and read parameter, and so this reads returns to the what? The read logical values of the whole the process getting the image, and the frame contains to the what? The R simple matrix or the NumPy matrix to what? To represents the whole the image in the matrix format. Okay, and so after that we should check the what? The read values. It's a logical values, and then if this is not okay, and then we should give the what? The error could not read frame at this time, and also we should give the what? The break value in here. Okay, so for the face recognition algorithms, we should only create the what? The gray frame in here, CV2 color and frame should be converted into the what? The color BGR to gray. Okay, this is a simple idiom for the what? For the detection of the face from a given image. Okay, and so this frame contains to the what? The blue, green, red values of the what? The R process. But we should convert it to what? The grayscale format, which means that we scale all the pixel values into the what? The 0 and 1 in here, or 16 millions values, okay? Because if we have the red-green format, we have the 3 matrices, or which means that we have the blue matrices, green matrices, and the red matrices, which is scales of the, what? The tones of this image. But if we use this term, and so we can scale the whole image into the what? The 0 to 16 million values, or we can normalize these values at this time with what? The 0 and 1 values, okay? So why do we do that? We should create the phases in here, like this one. Self phase cascade is defined in here, and we can detect the multi-scale format in here. We should provide the gray frame in here, and after that we should give the scale factor 1.3. This is a default value. I choose it in here, and mean neighbors is the equals to the what? Is equals to 5, okay? This is the parameters of the what? The detection of the face recognition algorithm. And so this scales factor convert this gray frame image into the what? Into the another scale. And we can search the what? The prepared filter convolution operation, which means that we should check the whole image into the what? Into the detect the face. And so if we have the same pixel with the what? With the filter, hard filter, and then we can get the what? This is the face, okay? We can say that. Mean neighbors means that if we have this parameter in here like this one, and so we can scale also the face pixels in here. For example, if we have the not the face but the similar pattern, and so we can check, and also we can approve this is the face, because in every frame we cannot do the what? The detection process. We have some noises, or we have some not appropriate poses for the faces in here, but this mean neighbor to what? To set this value in a what? The adaptive way, or the some robust way in here, okay? After that we should give the what? This face contains the what? The detected faces in the image. And so we can create the what? The 4 x, y, w and h value in faces. This is the R parameters in here like this one. And so we can create what? The rectangle formulation in here. Frame x and y is the position of the point 1, and also we should give the x plus w and y plus h, which means that this is the starting point of the what? The detected image in the image matrix. And so this w and h value contains to the what? The total face area, or the dimensions. And so if we have two positions, for example 10, 10, and this is 5, and so we have the 10 to 15 rectangle on this image, okay? And also we should give the what? The blue color in here like this one. This is the blue tones 255, and 0 and 0 is assigned in here, this total blue line. And we should give the what? This term thickness values of this pudding. And after that we should give the what? The put text in order to what? In order to imply the whole the faces process, okay? And so we should assign the frame to the what? The person, okay? And after that we should give the specific position of these terms like this one, y minus 10, which means that this is the what? The upper side should be given, or putting a text to the what? With the name of the person in here. And also we should give the what? The CV2 font, Hershey simplex. These are font type in here, and font scale 0.9, and color values in here 255, okay? This is a blue line, and also we should give the what the thickness value, and also CV2 line a parameter should be given in here. Okay, and so in each run this function draw the what our image or face detected from our algorithm. Okay, and so this detects or returns to the what the general position for the image. Okay, so after that we should give the what the CV2 in show in here camera video with the frame values. Okay, and after that we should give the CV2 weight K and 0x ff is equal to port Q. Okay, and also we should give the what in this case the break, and self cap release must be called in here, and CV2 destroy all the windows should be calling in here. Okay, so if I run this code, and then we have the initialization function or the what the constructor function in here like this one, and so we have also run face recognition algorithm. This is simple. We need to convert the whole image into the gray frame or grayscale format, and then we should call the what the detect multiscale format in here, and after that we can draw this image by this one. Okay, this is simple to what to draw a rectangle formulation, to what to create the exact pose values on the image. Okay, so if I run this code, and then you will see that we have the rectangle in here. This person is written in here like this one. Okay, and so if I turn around, and then our face recognition to what to terminate it, because we cannot simplify or classify the our face in here. But if I turn or the directly seeing to the what camera, and then this filter contains the whole image formats, and then it's evaluate to what to pixels to what to find the exact position of the detected face. Okay, so one important thing should be know that in here, if I close the camera, and then I have a greater line in here, but if I get away from this camera, just see that this line is automatically updated at this time. Okay, so in this case we have this formulation in here, but the detect multiscale factor returns to the what to our basic information, to the what to create this a rectangle blue line in here. Okay, for example, if I choose the what the scale factor to do 10 in this case, what happened? Just see that now I don't get or detect the face to what to clear way. Okay, and so our algorithm performance is decreased to the what to the away format, or if we have the some line or the distance from the camera, it's gather, and the longer or increased in time, and then we cannot detect to what to our face. Okay, just simple example is that is because the scale factor is contains to the what to scale the R format, and so in 20, and then we don't have any image like this one. Just see that this is the basic utilization for the what for the image recognition. But if I choose the 5 in here, and so I don't have any image in here, any detection. Or if I choose the 3 value in here, like this one, and so we have these person values, okay? And so if I remove, and then our face cannot be detected because the our face is scaled to the what? To the bigger one in here. And so we don't have any image or the detection. But if I choose the 1.5 in here, and so which means that the scale factor is not terminated in here like this one. Just see that this is the longer distance from the webcam, but our algorithm is okay right now, okay? Or if I choose the 1 in this case, just see that this detection cannot be smaller than this one. For example, if I choose this term in here like this one, just see that there are 2 person in here right now, okay? And so we don't have any image operation in here, and then I have 2 detected person. And so if we have choose to be used to what the scale factor in here, and then we should give the appropriate values of these terms, especially for the for the implementation of the person, okay? So this is the default values of the 1.3 in here. But what happens if I choose or change the mean neighbors parameter? Firstly, you need to understand that this scale factor is given in here like this one, this 5. And so if I choose the 1 at this case, just see that we have many updates in the in our person, but we have also another line in here, okay? And then if I choose the 10 in here, we have the increased number in here in the mean neighbors, and so our algorithm is more stabilized than before, right? We have this combination, and then we get these terms. Or if we have the 50 values in here, just the many values this time, and so we don't have any knowledge about the faces, okay? But if I choose the 10 in here, is more stabilized. But if we have choose the bigger number, and then we don't have any person image in here. But if I choose the 1 value like before in this case, and so we have some wrong detected person, because if we have these faces in here like this one, and so if I choose the 1 values, and then we don't have any stabilization to detect this person, because sometimes our face is given in the upper side of my hair, okay? And so this algorithm detected. But if I choose this mean neighbor, it's some kind of filter in here, and then we can stabilize our faces in here, okay? But we don't have any right side or the left side posture in this filter. In order to get this information, and then you may utilize some advanced algorithm like the YOLO or the media pipe. In order to get the true face detection algorithm for a given image, okay? So this is the first example about the face recognition. How about the eye recognition algorithm? We can do that. iRecog.py, okay? So for the eye recognition algorithm, we have some more complex structure. Firstly, we can give the example of this one, x1, eye and face recognition algorithm. Okay, so as always we do, we need to import the CV2 in here like this one, and we should define the class face eye detection class in here like this one, and also we should give the if main double term in here, and so main should be given in here, and face eye detection is defined with the face eye detection constructor in here like this one. Okay, and also we should call the face eye detection instance run detection format. But in this case we have to both the face detection and eye detection using the CV2 library. Okay, so in the first place we should create the def init constructor function self and camera index is equal to 0. Okay, and self cap is defined with the CV2 video capture with the default values or the camera index values on this term, and after that self cap set CV2 cap prop FPS property camera property FPS is assigned with the 30 values, and also we should define the self face cascade is equal to the CV2 cascade classifier with the data of the CV2 data har cascades plus, and also we should give to the har. Okay, it's the R simple name of the har cascade frontal face default .xml. Okay, but also we should give the eye cascade. Okay, CV2 cascade classifier, the parameters of the CV2 data har cascades plus, but in this case we should give the har cascade eye.xml. And so in the first place we should utilize the har cascade frontal face in here and default values. Okay, because this returns to the detected image or the faces from a given to an image or the pictures or the webcam. But in the eye cascade we have the different filter, but in the type of the same type har cascade. This is a filter type, but this har cascade eye contains for a specialized coefficients for the detection of the eye for a given image. Okay, and so also we should initialize some variables to be stabilized our algorithm for eye position, because we need to draw the rectangle for for also an eye, but eye is difficult or is more difficult for for a given face algorithm. Okay, and so self eye position is given as a list, and self counter threshold value is equal to the 10, which means that if we have the 10 detected eye algorithms or the outputs, and then this counter threshold must be passed, and so which means that this is the correct eye position. This is just kind of the low pass filter design in here. Okay, and so self distance threshold is equal to the 5. Okay, and so we can adjust these terms in here like this one, and so our algorithm produced the eye positions, but these eye positions is at the same time we have the 10 same results or the similar results, and then this counter threshold to what increased in here. And then if we pass the 10 value in here, which means that we have the 10 similar eye positions at this time with the distance of 5, and so we can assign that this is the true eye position. This is just kind of the low pass filter for the stabilization of the detection of the eyes in here, because the face is more general application, face detection, but in the eye there could be a problem, okay, because we have the wrong detection or the many wrong detection in here. And also we should give this function detect face and eyes, okay, in here. So we can obtain the frame values in here. Firstly, we should turn the grayscale format or gray frame in here, like this one, CVT, CVT color frame, CVT color BGR to gray format, and faces can be obtained with the self face cascade. This is a specialized function with the multi-scale format, and so gray frame is given in here, and scale factor 1.3, and mean neighbors is equal to 5. This mean neighbors is like of this algorithm, but this is the expansion of this algorithm, okay. For the face we have the 5 detected face to draw the face location or get the face location, but in eye we have also this kind of positions in here, okay. So if we have these positions, and then we should give the for X, Y, W and H in faces. These are the face position, and CVT rectangle can be drawn with the parameters of the X and Y. It's the upper vertical and horizontal side of the R rectangle, X plus W and X, Y plus H in here, and we use the blue line in here like this one, and we can get the thickness values, okay. For the region of interest for eyes within face recognition, which means that if we have the face position, and then we can also focus on this image to search the eyes, okay. And so if we have detected faces in here, and then we can search the eyes within this face image, and which means that gray, the region of interest gray frame, can be created with the Y Y plus H and X to X plus W, okay. And this ROI color can be assigned with the frame Y plus H and X plus W. Because these terms gives to to our algorithm results, because this rectangle contains the whole face, but this face also should be applied or transformed into the another image, because this face must contain our eyes, okay. Not the total image should be processed in here, but the face image should be processed. And so eyes can be obtained with the self eye cascade detect multi-scale application. Roy gray should be given in here like this one, gray frame, and also we should give the scale factor 1.1, mean neighbors 2, and we should give the what the mean size for the what 30 and 30 is the minimum size of the what the eye in here, and also we should give the more stabilized version 50 and 50 for the greater eye in here. Okay, so if we have this algorithm, and then we should give the 4 EX, IX, IY, IW and IH in eyes. Okay, CV2 rectangle function should be given in here with the what the ROI color function. This is the gray frame, not the gray frame, RGB frame of the what the R picture, and then CV2 EX EY should be drawing EX plus EW and EY plus EH. Okay, and also we should give the what the line of these terms, like this one 250 500 and thickness values. Okay, and also the eye position should be assigned with the what, with the arithmetic mean values of these terms. For example, X plus EX plus EW, this is the what, this is the difference values between the what, between the R image. For example, this 10 and we have the 5 pixels in here, or 10 pixels in here, and so the eye is the what is at the position of the what the mean values of these pixels. Okay, and so we should divide into the what the 2. Okay, and Y plus EY plus EH divided by 2 should be given in here. Okay, and self eye positions should be stored in the what the append eye position. This is what, this is written eye, but what happens if I choose the what the eye position or contains the whole the values of the eye position in the list? And so if we have this list, and then we can apply the discounter threshold values in here. For example, if we have the similar eye detection algorithms or the positions in the given the what the X and Y and so we have this eye positions, and then and also we have the distance threshold values in here with the values of the 5, and then 10 values is compared with each other to what, to subtract each other, and then if we have the smaller values or smaller distance values like the 5, and then this is the true eye position. Okay, and so self eye positions is assigned with what the self eye positions minus self counter threshold values to at the end of this code. And then if we have this term, we can check the what the len self eye positions is equals to the what the self counter threshold, which means that we have the 10 image or eye image with the similar positions, and we can also give the what the self r eye positions close function returns to the true values, and then we can assign to the what these terms CV2 rectangle, this the R new positions for the eye on the what, on the frame. Okay, X plus EX, Y plus EY, and we should give also X plus EX plus EW. This is the eye position, Y and EY. This is what the face position, but if we add the EH, this is the eye position. Okay, and also we should give the what the 0 250 0. This the red, green, blue, green line is added in here, and we should also give the what the 2 value is the thickness. Okay. This is the total algorithm. But if we have this information, and then we should give the what, the one line is given in here, we should create the def r I positions close. which means that we should calculate what the average position of the last n I positions in here. In order to do that, the average positions can be assigned with what the tuple values int sum x divided by len x in here, like this one, the 4x in zip, the argumentative parameters self I positions. Okay, and so we can check the whole the positions or the average positions for the what, for 10 image or 10 positions, and then we can calculate to the what, distance. Okay, for this distance we should create the what, the this term like this one, the x average position 0 value, this is the x position, and the total values in here like this one, this is the average position. For example, this could be the 7 or 10 values, but the present position is the what, the 13, and which means that we have the smallest values with the 5, and so we can assign to the what, to the right I position. But we have the some more complex formulation in here. It's the Mahalanobis distance can be utilized to measure this effect. Average position 1, and these terms square form over 0.5 is the SQRT form, and for x and y in to what, the self I position. Okay, and so at each case this distance is calculated, and after that, if we have this information in here, return all values, the distance is smaller than self distance threshold for distance in distance. Okay, and so this 10 image, if we have this 10 image in here like this one, and all the positions are correct or similar, and then this function returns to the what, true values, and then we can assign to what, the I position. Okay, so if we have this information in here like this one, and then we can create the run detection function. As always we do, if not self cap is opened, and then we can print what, the error could not open camera. Okay, and return these values, and while true, this is an endless loop for our application, and then the read and frame should be assigned with what, the self cap read function, and if not read in here, and we should print the what, the error could not read frame should give the break, and the frame with detection, the new algorithm in here, self detect face and eyes with the frame input, and CV2 im show should be given in here, the face and eye detection frame with detection should be assigned. Okay, and also we should give the if CV2 wait key function 1 and 0 xff is equal to word q, we should give the break. Okay, and after that we should release the cap parameter, and CV2 destroy all windows should be called in here. Okay, so if the name of this main is given in here like this one, and then we can run the codes. If I run this code, we have the face eye detection in here, run detection, and also size height CV2 imshow. Where is it? CV2 imshow function, frame width detection, and frame, and this term in here like this one, and if I run this code again, we have the sum position. Okay. So the previous code we have the sum problem. Instead, for example, the index values may be not written in here, but in this code we have the eye and faces. Okay. Just like this one. We have the eye position in a stable format. Okay. And so you can turn into your program into this one, and so we can set the different ROI values, region of interest values, or the neighbor values, or the scale factor to detect the image or the faces or the eye from your webcam or the YouTube videos. Okay. So, any question? Okay, I will share this code in the classroom code, and then that's all for this lesson. And in the next lesson we will talk about the text detection and the curve fitting algorithms. Okay.